Recognizing people is important to the human infant. They are the objects that provide nurturance and protection. Nobel Prize winning Austrian ethologist Konrad Lorenz is famous for uncovering an early attachment process, which he called imprinting. In Lorenz's notion of imprinting following birth, precocial animals, those born in a mature state such as geese and lambs, enter a critical period during which they rapidly learn the visual and other characteristics of their mother. At around 25 hours following hatching, domestic chickens and geese, for example, will have learned the specific characteristics of their mother, and from this point on will avoid other adults of their species. Lorenz saw this special learning process as the outcome of natural selection, since those individuals that rapidly became attached to their mother would be more likely to benefit from the protection that she provides, and thereby pass on their genes for this specific early learning process. He also suggested that the young emerge without a preference as to what the imprinting object might be, since in the natural world the object will almost certainly be their mother. However, Konrad Lorenz imprinted young geese on himself. One of the most endearing pictures of Lorenz shows him swimming in a lake surrounded by his own clutch of baby geese. To return to human development, clearly the ability to recognize conspecifics is crucial for a baby's survival and future development. Perhaps even more so than it is for chicks, given the importance of social interaction in human life. There has long been evidence that face-like stimuli are interesting to infants. Fantz compared newborn infants' looking times at a variety of different visual stimuli, each presented to the infant in pairs. The stimuli consisted of patches of color, patterns such as bullseyes and checkerboards, and stimuli which looked like simple faces. Fantz found that infants spent significantly more time looking at the stimuli that resembled faces than any of the others. Fantz's results might be taken as suggesting that infants are born with some knowledge of what a human face looks like, but how detailed is this knowledge? To investigate this, Johnson and Morton conducted a similar study, but they were interested in whether Fantz's study indicated that infants were born with a fully functioning face identification system, or whether they were born with only sketchy knowledge of faces, the details being filled in by experience of faces in the world. Johnson and Morton, like Fantz, used a preferential looking paradigm in which the infant was presented with stimuli shown in this figure. Johnson and Morton's results show that for neonates, both the primitive face and the realistic face elicit approximately equal looking times, indicating that they are equally interesting, and both of these are preferred to the other stimuli. The results are rather different for the 4-month-olds. Although the primitive face is still more interesting than the checkerboard pattern and the scrambled face, the realistic face elicits much longer looking times. Johnson and Morton interpret these results as suggesting that infants are born with some preference for face-like stimuli, but it is by no means fully specified. Experience is still needed to flesh out the details. For instance, at 6 months, human infants can discriminate monkey faces as well as human faces, but by 9 months, this ability to discriminate monkey faces disappears unless exposure to monkey faces continues. Similar results were found for Japanese macaques, who learn to prefer monkey to human faces when given experiences with monkey faces, or prefer human to monkey faces when given experience with human faces. Even newborn babies are social animals in that they are motivated to look at face-like stimuli. Moreover, within this general preference for faces, it appears that some faces are preferred over others. Research suggests that newborns show a preference for their mother's face rather than the face of a stranger. It should be pointed out here that there is almost certainly nothing special about the mother. The preferential allocation of attention seems to be towards the person with whom the neonate has had the closest contact in the hours following birth. This is usually, but not always, the biological mother. Baby's knowledge of faces seems to be quite sketchy, however, as the preference disappeared if the mother and the non-mother were wearing identical wigs, suggesting that the infant was using cues, such as the outline of the face, more than the internal features.
Psychologists used to believe that the baby human's mind was one great, blooming, buzzing confusion. But the baby human comes into the world already equipped with the capacity to think, reason, to learn about the world and about itself. At At the moment, 2-week-old Heather lives only in the immediate world of the senses. Like all newborns, she responds to a series of stimuli, but they have no meaning for her. A play of light and dark from the window captures her interest. Her eyesight is not developed yet, so this is what she sees. The patches on the wall seem to come alive and beckon her. At this young age, Heather has already embarked on the huge task of making sense of her surroundings. Now her eyes turn to the bars of her crib. They look like thick stripes, just the right size for her eyes to discern. But what the baby human responds to most of all is the human face.
Hello. Good morning.
Heather is gazing at the most important face she's encountered so far. At 12 inches, what she sees are mainly contrasts of light and dark where the features are. But her clearest view is from 6 inches away, an easy distance to communicate love between mother and child. It seems nature has prepared the baby human from birth to pay attention to the face, as if saying, look carefully. Something that looks like this is going to be very important for your survival.
Hi there. Okay, are you all set?
At Daphne Morer's lab, Terry Lewis is part of a group studying the phenomenon of this attraction and how it develops in the first 3 months of life.
Are you ready?
10-day-old Dylan is shown a card with 2 images on it. The right side has 3 blobs representing the rudimentary configuration of the human face. The left has the blobs inverted.
Good, you're looking. Very good.
Dylan is drawn to the image that resembles the human face. But what is it that he's attracted to?
Careful, I might trick you.
To find out, they show Dylan another card.
Okay, are you all set?
One side has the blurry image of a face, and the other side was created to represent only the light and dark contrasts of a face. Dylan prefers to look at the side with the contrasts of a face, which indicates that it's not the features themselves that the baby human reads at this age, but the areas of contrast created by those features. So what 2-week-old Heather is really fascinated with is the contrast between light and shadow created by her mother's eyes, mouth, and hairline. But she doesn't know yet what they mean. Back at the lab, 6-week-old Devon is shown the same card.
How about these guys now?
Unlike Dylan, he turns to the image that looks more like a face. The other image no longer interests him. So what happened in those 4 short weeks that separate Heather and Devon? Researchers believe that this is when the baby human's higher brain centers, which are sensitive to visual stimuli, take over. And that is what's directing Devon's gaze and begins to give meaning to what he sees. At the same time, other regions of the higher brain centers are preparing the baby human to think and reason. These exceptional capacities are what set humans apart from the rest of the animal kingdom. Gavin is 8 weeks. As he begins to interact with his environment, the world around him takes on new meaning. He looks at his mother with new eyes. During these critical early weeks, new neural pathways in the brain are forged. The more things the baby human sees, the more this ability surges. At 2 months of age, this is what Gavin's world looks like to him. His life thus far has been a kaleidoscope of sights, sounds, sensations, and smells. But he's now beginning to make connections between them.
Let's get this all changed for you. There we go.
He suddenly realizes a remarkable thing,
He's a happy boy then. There you go. Oh,
that the sound of the voice and the moving lips of his mother are related.
good boy.
For the first time, he can put together sight and sound. Out of the chaotic flow of impressions, he slowly realizes that the world isn't one thing. He now begins to distinguish the amazing world of objects.
Care must be taken when interpreting the results of these studies. They do not suggest that neonates in any way recognize their mother in the way that adults do. Face recognition is a complicated process that involves, among other things, a knowledge that the face denotes a unique individual, some knowledge about that person, and often some emotional response to them. What we are seeing here is just a preference for one stimulus over another, and a relatively small preference at that. There is no reason to assume that the neonate's preference for their mother's face indicates that they assume that this mother is a unique individual. The mother's face could merely be a collection of stimuli that is attractive to the infant as a result of repeated exposure. Moreover, the preference is a small one, as research by Bushnell et al. Shows that it is fragile and can be disrupted by superficial changes. It takes children many months before they really respond to a familiar face in a predictable way. Neville et al. Conducted brain imaging studies on 6 and 12-month-old infants' face processing abilities. It was found that 6-month-olds used a variety of brain regions across both hemispheres for faces, whereas at 12 months, processing had become more localized in the right hemisphere, more like that of adults. This suggests that although infants are competent face processors, this ability undergoes much refinement over the months as a result of experience. Whatever is happening here, it is clear that the mechanism is more complex and extended than one of simply imprinting on an object in the way that chicks do.